Alrighty, notes 9.2 part 1. We start with concentration. What is concentration? Concentration, again, is just the amount of stuff that's dissolved in solvent. Okay, so you got more stuff dissolved in solvent, you got a higher concentration. So let's look at this first example here. A solution with a little solute is considered dilute, while one with a lot of solute is concentrated. Compare solutions of copper chloride. These are 0.05 molar, 0.1 molar, and 0.05 molar respectively. Now you're looking at this and you might think to yourself, wait a second, is this a typo? We've got 0.05 molar on both. Did they mean to say 0.15? No, they didn't. There's two different ways we can make this 0.05 molar solution. Okay, and we're about to find out what that is. Solution 1, we would take, to make a 0.05 molar solution, we take 0.67 grams of copper chloride in 100 mils of solution. Okay, they really should have said 100 mils of solution. Solution 2, to get this 0.10 molar solution, we take 1.34 grams of copper chloride in a 100 mil flask, and notice the relationship here. We just double. We double the amount of solute in the same amount of solution, 100 mils. Well, could we again turn this into a 0.05 molar solution? Yeah, of course we can. How do we do that? We take that same amount of dissolved copper chloride, 1.34 grams, and we just double the amount of water. When you double the amount of water to 200 mils, then what happens is the concentration will drop in half. So the relationship then mathematically is, we can make the conclusion that concentration is directly related to the amount of solute and inversely related to the volume of solvent. Solvent, not just volume of solvent. Okay, go ahead and let me zoom in a little bit. Let me try to zoom in for you, and then I'll have you copy this. Okay, alrighty, go ahead and copy that. And again, that's volume of solvent. Okay. Alright, so then the next thing is, well, how do we prepare a solution in chemistry? We use this thing right here. It's called a volumetric flask, okay? This is a 100 ml volumetric flask, and it's got this gradation, or this graduation rather, right there, okay? It's got a graduation right there. And that line is very precise. It's within 0.1 milliliters. And it will tell us how much solution we need to add, how much solvent rather, how much water we need to add to create a very, very accurate solution. Okay, so how do we do this? We obtain a volumetric flask for the volume of solution you want to prepare. In this case, if you want a little bit of solution, just 100 mils, you use a little flask. If you need a liter, then you use a bigger flask. Okay, weigh out the mass of solute using a balance. I don't know how much this is, but let's just say it's about 3 or 4 grams. It might be more than that. It might be, I don't know, it doesn't matter. Fill the volumetric flask with distilled water. No, sorry, transfer the solute to the volumetric flask. So I would transfer this amount of solute into this flask. Okay, let's say 4 grams into this flask. Then fill the flask with water. Stir the solution until the solute dissolves, and then that's how you have a solution. One more thing you have to do is, after you weigh out the mass of the solute using a balance, convert to moles. Convert to moles, okay? You got to convert it to moles. So in this case, I don't know how many moles this would be, but I would use the molar mass. I'd find out what the chemical formula is, use the molar mass, and convert this to moles. To measure concentration, we use units of molarity. Actually, go ahead and copy all of this. Okay, to measure concentration, we use the units of molarity, and that is moles of solute divided by liters of solution, or big M equals little n, which is moles, that's number of moles, over V, that's volume in liters, okay? Note that N is moles and V is always in liters. Okay, so go ahead and copy that. And let's go ahead and solve some work here. Use IESA to show work. That's identify variables, write the equation, substitute, and solve, then write the answer. Basically, you need to identify all of your variables. You need to identify all of your variables, and then you need to plug in and solve. Let's go ahead and do one. Find the molarity if 0.25 moles of calcium chloride is dissolved to prepare 1.2 liters of solution. So in this case, N equals 0.25 moles and volume equals 1.20 liters. Big M equals, we don't know. Okay, so here's how you solve. Big M equals N divided by V, which equals 0.25 moles over 1.20 liters. Okay. Make sure you guys can see that. Let me zoom in a little bit more. Okay. And when we do that math, we should get, what do we get? 0.21 molar solution. 0.21 molar solution. Okay, that should be your answer. Alright, next, find the total volume of a 0.30 molar KBr solution if 0.72 moles of KBr is dissolved. Hey, when you guys get these types of questions, this right here, it looks confusing, and it kind of is, I guess. That right there can be unpacked. You need to kind of unpack this M here, this big M. Okay, and what do I mean by that? I mean what this really means is 0.30 moles per 1 liter. And notice, when you write it like that, it can be used as a conversion factor. Okay, so you can flip this upside down if you need to. This right here, that is your given. That's your given. So remember, you write your given out first, right? So you're going to do it like this. You say point here, let me just do this so that you guys don't make a mistake. 0.72 moles of KBr over 1. That's the first thing you need to do. Then you look at this conversion factor and you're going, okay, we're going from moles to grams, right? No, I'm sorry, we're going from moles to volume. So we go like this. We're going from moles to volume in liters, right? So now I look at this thing, I'm going, okay, I'm going from moles to liters. That means moles is on the bottom, so I can cancel it. Now I look back over here and I write 0.30 moles on the bottom and 1 liter on top. I can cancel out my moles. I'm now in my units of liters. So if I multiply everything out, I get, check this out, I get 0.72 liters of KBr over moles? No, over 0.30. There is no units in the bottom because they canceled. That's how I know I've got the right answer. Now I just simplify this by dividing 0.72 by 0.30. I get 2.4 liters of KBr. Okay, 2.4 liters of KBr. Find the mass of NaCl needed to prepare a 2.50 liters of a 0.15 molar solution. Okay, so this one's a little bit trickier, and what you need to do is this. We go from liters to moles to grams. It's got 3 steps to it. Big G, little g. Okay, liters to moles to grams. How do I do it? I have to use this, and I have to use the molar mass. So this one's a little bit trickier. You know what I'm going to do? I'll go ahead and start a new video for this one. Okay.